Assalamualaikum and a very good day to my panelist associate Professor Dr. Amir Radzi bin Ghani and Dr. Natasha binti Ahmad and to everyone watching this presentation. First of all, my name is Nurul Zulhusni by Zulkiflee. My student ID is 2018292428 and I will present to you my final year project proposal, Structural Integrity of Oil and Gas Piping Repair Clamp. This project is under supervision of Hazran Husain and Co-supervisor Mr. Suhairil Meon. First, let's go through the outline of this presentation. This presentation will include introduction to the project, a brief findings on the literature review, problem statement, objective, scope and limitation of the project, methodology of the project, the result or outcome expected to be gained from this project, and lastly is project planning. The title for this project is Structural Integrity of Oil and Gas Piping Repair Clamp. The main focus is on the clamping device. Clamping device is basically a repair types used for repair purpose on subsea pipelines. The clamping device is typically installed on damaged or leaking pipes. It covers the damaged part from being exposed and prevent further damage. It also will protect the pipeline securely in place with no displacement permitted. The clamping device is basically a metallic-based device consists of two piece flange shelves with oversized annuli that fit over the pipe. Seals is one of the most important parts of a clamping device. What about pipelines? The subsea pipelines is used to transport or fluid in the oil and gas industry. Damage can happen on the pipeline due to environmental factors such as corrosion. There are many types of damage can occur to the pipeline. One of the damage that can be fixed by using clamping device is leakage. Leakage can be caused by internal or external metal loss and sometimes due to crack in welded seams, joints or on the pipe. 3. Repair situation considered are pipe subject to external metal loss, pipe subject to internal metal loss and leaks plumbing parts. Next is about the structural integrity. Structural integrity is the ability of an object to hold together under a load including its own weight without unnecessarily breaking or deforming either structural element of a structure consisting of several components. Clamping devices are built with structural integrity to avoid serious failure that can result in harm, significant damage, death, or monetary loss. Based on findings from literature review, clamps are common methods of fixing pipes with leakage defects in the oil and gas industry. The primary components of the clamping device are the main body, axial lock, circumferential sealing module, tightening flange, friction slip, and sacrificial anode. There are three main repair circumstances considered with pipe subject to external metal loss, pipe subject to internal metal loss, and leaking plumbing component. Based on historical results from 2010 to 2015, the three causes of oil pipeline failure are deterioration, pipes or well material failure, and equipment failure, while gas failure is pipes or well material failure, drilling damage, and deterioration. In 2014, Malaysia was shocked by the Petronas gas pipeline explosion in Sarawak, which damaged part of Sabah to Sarawak gas pipeline. Therefore, the clamping device need to be analysed its integrity for the safety use in the industry. The clamping system shall satisfy the following technological specification to deal with other operating conditions. First, it can safely protect pipeline in place without permitting displacement between structure and the pipeline during operation. Next, pipeline with diameter should be suitable to some degree. Oil and gas pipeline repairs can be divided generally into two forms. The first include cut-off procedure and welding. The second includes some external sort of repair. The primary output of the clamp is sealing ability. It needs the sealing material not only to have a certain degree of oil resistant, corrosion resistant, but also a certain degree of low temperature resistant and set of compression. Based on the finding, structural integrity and material strength of the clamping device can be analysed using finite element analysis. The overall structural analysis model of the pipe clamp can be analysed using ANSYS commercial package. It can analyse the stress distribution of the pipe clamp under operating pressure. Last but not least, minimization of shutdown time is one of the key considerations in selecting the repair technique. There is a few problem statements in this project. First, the structural stability of material quality of the clamping device. Second, the deformation of the clamping device after a period of time due to stress. And lastly is the capability of the device to withstand the strain, stress and load applied. The objectives of this project is to investigate the ability of structural integrity and material strength of clamping device under a load without breaking or deforming the structure. Next, the purpose of this project is to stimulate the clamping device for piping maintenance with different thickness by using finite element analysis simulation. What are the scope and limitation of the project? It has been decided to design the clamping device using CAD software, which is CATIA. The drawing and dimension of the clamping device is obtained from a client. Next, the model design will be imported into ANSYS using either step file or IDS file for further analysis. The analysis will be done with 3 different thickness of clamping device, which are 36 mm, the original thickness 38 mm, and lastly 40 mm. It is also considered that the force distributed from the pipe is uniform. Material to be applied for the plate bolt nut is SS 5.6, 70, SA 193B7 and SA 1942H respectively. Methodology of the project. The flowchart has been constructed to show the workflow of the project. Started with CAD modeling using CATIA to build the model of the clamping design. It is then followed by structural analysis using ANSYS. The model has been imported into ANSYS using IDS file type. The analysis using ANSYS will be done during FYP2 phase. The result will then be obtained after the structural analysis is conducted. Final result that have fulfilled the objective of the project will be discussed in the final thesis. The following figure shows the model of the clamping design drawn using CATIA. The clamping device consists of insert clamp, stiffener ring, injection point, bolts and nuts. This figure shows the imported design into ANSYS. The simulation will be started during FYP2 phase. The material properties of the clamping device will be used is grade 70 carbon steel A516. As mentioned earlier, different thickness will be used, 36 mm, 38 mm and 40 mm. The ultimate tensile strength is about 485 to 620 MPa, yield tensile strength is 260 MPa, modulus elasticity is 200 GPa, Poisson ratio is 0.29 and shear modulus is 80 GPa. The result expected out of this project is the structural integrity and material strength of the clamping device is able to withstand the applied load without breaking or deforming the structure. Second, the structural integrity of clamping device with different thickness can be simulated using finite element analysis simulation. Through this result, the best thickness can be suggested. The material used also can be decided whether it fits the application for damage repair on pipelines. This is my project planning for FYP1 and FYP2. So, all the activities is according to the plan. That's all from me for my proposal presentation, Structural Integrity of Oil and Gas Piping Repair Clamp. Thank you to Supervisor IR Hazran Husain and Co-supervisor Mr. Muhammad Suhairil Meon, and to all panelists, Associate Professor IR Dr. Amir Radzi bin Ghani and Dr. Natasha binti Ahmad. For any question, please do not hesitate to contact me. Thank you for your time.